Hey guys, welcome to the Maths Club again. If you are just joining us, you're welcome. We'll be waiting for you and we're glad to have you here. If you're a returning viewer, welcome back again to the Maths Club. At the time of recording this video, we are ending the year 2024. So if you're watching it, probably I'll be saying Happy New Year to you. In this particular video, we're going to be looking at longitude and latitude. What is longitude? What is latitude? And how do they relate in accordance with the WAEC past question? So let's get started. Longitude. When you say longitude, you're talking about imaginary lines that run from the North Pole to the South Pole, measuring the east-west position. Let me break it down for you. You know the way the world is. When they say, oh, draw the Earth, you draw something like a sphere. Even though some people say that the Earth is geoid in shape, you draw a sphere. In that sphere, you say the top part is the north, the bottom part is the south, the left side is the west, and then the right side is the east. Now, the longitude are those lines that run from the top to the bottom. So you see, the lines will not be straight, right? Because the Earth is kind of spherical, kind of geoid. It will be kind of curved. So all those curved lines that run from the top to the bottom, they are called longitude. Look at this. So if you see this place here, you see that you see these lines curving here. These are longitudinal lines. And you can see, why did they say they are measuring east-west position? You can see that they are moving to the right or they are moving to the left. So you can see this place here, this one here is at 10 degrees, this one is at 20 degrees, this one is at 30 degrees. So it's increasing to the right and it's also increasing to the left. So that is why if we say our value here, our longitudinal line is 30 degrees east, we know that we are going to come to this side here, because this is where the east is. We say, oh, okay, this should be maybe 10, 20, 30. Then we'll draw this line here. So we say this 30 degrees east. 30 degrees east. When you say 30 degrees east, you're already talking about longitude. You already know that because it's measuring the east-west positions. Most of these things will make sense again by the time we start doing examples. So you can see that longitude ranges from 0 to 180 degrees east. So you can see this 0. The 0 is this line, which is the Greenwich meridian line. This green line, this is like this, the starting point. And it increases as you go left and as you go right. So it ranges from 0 degrees to 180 degrees east and 0 degrees to 180 degrees west, making a total range of 0 degrees to 360 degrees. So you can see it's this. If you go like this, you can see 180 degrees from 0 degrees to 180 degrees, either the left side or the right side. The next one, we're going to look at latitude. So when we say latitude, what does it mean? So it says these are imaginary lines that run parallel to the equator, measuring the north-south position. So I should have told you what the equator is. Just like in this particular cycle, this line here is like, you know, when you do your x and y, your x-axis and y-axis, that is where your Cartesian graph or your graph starts from. Same thing too for the Earth. The starting point for the y-axis, if I say that, is the Greenwich meridian line, GMT. I know you've heard sometimes, if you're a Nigerian, you say our time is GMT plus 1. If you're in Ghana, your time is GMT, and on like that, right? So you can see this is where they actually get all those time from. The reference point for the x-axis is the equator line. So this is like our x-axis, because this is the 0 position where both of them meet. You can see just like a normal x and y-axis. So this is the equator line and this is the Greenwich meridian line. So we said that latitude are imaginary lines that run parallel to the equator, measuring the north-south position. Remember, we said longitude measures the east-west position and latitude is measuring the north-south position. Let's see. So you can see that these are lines that run. This is the equator line. These are parallels. These are parallels. These are parallels. These are parallels. They are parallels. They are parallels. So all of them are making their own small cycle round, small cycle round, small cycle round, small cycle round, small cycle round. The latitude ranges from 0 degrees to 90 degrees north and 0 degrees to 90 degrees south, making a total range of 0 degrees to 180 degrees. So what do I mean? From this point here, if I wanted to get this line here, I'll just say go 30 degrees north. I know, okay, from this equator line, let me just draw it up to 30 degrees, and then I know that it is towards this direction. This is where my latitude line, as you can see, is a line, but it's a bit curved because of the shape of the earth. Same thing, so if I wanted 30 degrees south, from this equator, I will come down a bit, right? I'll use my eye, so this will be 30 degrees south. You can see the southern hemisphere and the northern hemisphere. Why do we use them? What's the essence of this longitude and latitude? First things first is that it is used for mapping and navigation. So you see all those times where you hear the stories of all those explorers, how they were able to move from one country to another country using map and using bearing and all of those things. It's because they know the latitude and longitude. So wherever you are now, if you give me the latitude and longitude of a location, I will find you. So it's foundational for mapping and navigation, and it helps to determine exact locations on Earth. This is the world map. You can see the world map. You can see the world map is just made up of imaginary lines of longitude and latitude. So you can see Africa here, you can see the USA here, and so on and so forth. Let's see, where is Nigeria? Nigeria is located at longitude, or at the latitude of 9 degrees 04 minutes and 39.9 seconds north. And as I read it, this is just saying degrees, this is saying minutes, this is saying seconds. And it's located on longitude 8 degrees 40 minutes 38.84 seconds east. So by the time if you have the map and you point these two positions, it'll take you straight to Nigeria. What of our Ghanaian brothers? Our Ghanaian brothers are located at 7 degrees 57 minutes 9.97 seconds north, and at latitude minus 1 degrees 01 minutes 50.56 seconds west. So once you know these locations, you can find anybody in Ghana or Nigeria. Okay, so that's basically it. Now there are some significant lines of latitude, just good for you to know. The 0 degree is known as the equator. We've seen that before. At 0 degree we have the equator, which divides the earth into the northern and southern hemisphere. If you've done geography, be instances of Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle, these are things that if you're interested, you can go and find out about. Another important line of latitude is north and south poles. The north pole and the south pole. Now, let's look at coordinates. We've talked about this a bit, but coordinates, especially latitude and longitude, they serve as a powerful tool for pinpointing locations on the Earth's surface with precision. In mathematics, we often use the Cartesian coordinates, our normal x and y graph, to represent points in a plane, right? We say, oh, we have the x-axis, which is like the horizontal, and we have the y-axis, which is like the vertical, and they intersect at the origin. Remember, our origin x-axis is the what? Great, is the equator, and then our origin y-axis is the what? Great, is the Greenwich Meridian line. So consider longitude as the x-axis in this earthly coordinate system. We are equating the Cartesian coordinate system to the earthly coordinate system. So the x-axis is the longitude. That tells you the west and the east positions. Does that make sense? Great. And then the prime meridian, which is 0 degree longitude, serves as the reference line, which is akin to the y-axis in the Cartesian system. Latitude, on the other hand, they take the role of the y-axis. We've talked about that before. We said the equator, which is 0 degree latitude, act as the reference line. So we now said a point on the Earth's surface can be expressed as just like we do say x comma y, right? So it's latitude comma longitude, basically, and they're measured in degrees, minutes, and seconds. We saw that with the latitude and longitude of Nigeria and Ghana. So this basically, it's look at Washington. Washington is somewhere that's 9 degrees north and 77 degrees west. So if you do that, you'll probably be saying hi to President Trump. Alright, so let's look at some examples when it comes to angular distance. How do we know the angular distance between the point and another point? Now we're already getting started. It says, find the angular distance between point A, which is 40 degrees north, 65 degrees east, latitude and longitude, and B 35 degrees south and 65 degrees east. Let's solve this together. So we have our heads. Let's assume that these are our heads. These are North Pole, these are South Pole, these are west, these are east, and these also are 0 degree, right? The equator or the equator line. So it says that the point A is 40 degrees north. 40 degrees north is talking about the what? Great, the latitude. So this is the north. We said it's 0 degrees to 90 degrees, right? 0 degrees to 90 degrees. This one is 0 to 180, is 0 to 180, right? So 40 degrees north should be somewhere, let's say somewhere here. So let me just draw a circle. Great. So I'll say this is my 40 degrees north. And then it's 65 degrees east. So because this 0 to 180 is not going to be exact, right? But we'll have to just make it work. So if this is it and it's at the east direction, I could just say this is my circle. So this is my line of longitude, right? And this 65 degrees east. So this point where they intersect is my point A. Same thing, so it says point B is at 35 degrees south. So this south, I'll just say 35 degrees should be somewhere here. So I'm just say 35 degrees south. So I'll come to the south and draw this line. And 65 degrees is so it's still maintaining the same line. So they are along the same line of longitude. Point A and point B are along the same line of longitude, right? Here and here, longitude. So I want to find the angular distance. So from this reference point here, if I draw a line to touch this point, and I draw a line to touch this point, right? You agree with me that the angle here would be 40 degrees. So let me just blow it up. So we have this. Let me draw this line here. So it's not going to be exact, right? This point A and this point B. So from here to this point, say this 40 degrees, because it went 40 degrees north, right? This is the equator, this is the line. It had to go up, so this 40 degrees. And from here it had to go down. This is what? 35 degrees. So what is now the angular distance between A and B? What do you think we're going to do? Great, so we're going to add them. So the angular distance would be equal to 40 degrees plus 35 degrees, and I'll give you 75 degrees. So that is the answer to this particular question. Let's see if we're correct. You can see the representation, this is more detailed, and then you can see our angular distance is 75 degrees. Example 2 now states that we should find the angular distance between x, which is 60 degrees north, 20 degrees west, and y, which is 40 degrees north and 20 degrees west. I want to just try it out by yourself. You don't have to get it, but get the diagram at least. Welcome back. Let's look at it together. So point x is at 60 degrees north and 20 degrees west. But let me label. These are north, these are south, these are west, these are east, these are also our equator, so just this is my 0 degrees, right? So to solve this, x is at 60 degrees north and 20 degrees west. So 60 degrees north will be somewhere here. So let me just draw this. Great. So these are 60 degrees north and 20 degrees west. So this west, if this is 20 degrees, remember this 0 to 180, so 20 degrees will be somewhere here. So this is 20 degrees west. So let me just label it and say this is 20. You must label all these things though, especially if it's a theory question. So this point here is my point x, and it now says that point y is 40 degrees north and 20 degrees west. So we're still maintaining this western position, but instead of it to be at 60 degrees now, it's at 40 degrees. So that will be somewhere here. So I could draw this and say this is 40 degrees north. So from this point here, we'll have something like this to join this guy, and from here we'll have something like this to join this guy. So it's something like this. Right, let's just assume something like that, like a cone of ice cream. So this is like our base point, right? So from year to year, it rose by 40 degrees north, right? So 40 degrees. So it rose. So this point here is 40 degrees. But yeah, it now rose again to 60 degrees. So it rose again to 60 degrees. So this is 60 degrees. But really, these are points X. Okay, I didn't label our points Y. So these are points Y. So these are points X and these are points Y. The angular distance between them is just this small span. This small span. But year to year is 60 degrees and year to year is 40 degrees. So what do you think I should do? Great, subtract, right? So the angular distance would be equal to 60 degrees minus 40 degrees, and that'll give me 20 degrees. So this is how you actually draw it and make it make sense. Let's see if our answer was correct. Great. So you can see the diagram, you can see the representation and everything. Example 3 states that P and Q are two places on the same circle of latitude 79 degrees south and P on the longitude 68 degrees east, while Q is on longitude 22 degrees west. The angular distance between them is what? Just take from WAEC 1999. Please pause the video and knock yourself out. Welcome back. Let's solve it together. Okay, so we're told that P and Q are on the same line of latitude 79 degrees south. So these are north, these are south, these are west, these are east. So 79 degrees south, remember this is from 0 to 90 degrees, right? So this will be somewhere pretty close to the end. So let's just say these are 79 degrees south. P is 68 degrees east, that's line of longitude. So on the east, this is 0 to 180. So 60 degrees job is somewhere, let's just say somewhere like this. Great. It's very hard to draw these lines when you're using a graphic pen. So this point P, so this is 68 degrees east, and Q is 22 degrees west. So 0 to 180, 22 degrees will just be somewhere here. So let me just draw this. So this point here is my point Q. Great. And this is 22 degrees west. Great. So from year to year, right, and then from year to year. So if I draw this out, although this is not any way represented, because this place is meant to be wider, since this is 60 degrees and this is 22 degrees, this place is meant to be wider. So you just have to forgive me. I'll try to represent this properly here. So something like this. Correct. So something like this. Here is 22 degrees. Here is 68 degrees. So the angular distance, this point Q, this point P. So what do you think I should do to find the angular distance? Great. So I'll just add. So the angular distance between both points is just going to be 22 degrees plus 68 degrees, which is what? 90 in this case. Right, so if they have the same line of latitude, the angular distance based on the longitudinal lines. If they have the same line of longitude, the angular distance based on the line of latitude. So just inverse. Remember this previous one, so it's based on the line of latitude because of how the question was arranged. It was the constant one was the line of longitude, but in this case the constant is the line of latitude, so the angular distance will be based on the lines of longitude. You can go back and this will make sense. Let's see if we're correct. So you can see our angular distance is 90 degrees, and this is properly represented. You can see this place is smaller than this place here because this one is 20 degrees west, this one is 60 degrees east. Example 4 now says that find the angular distance between x 30 degrees north and 10 degrees west and y 30 degrees north and 40 degrees west. I want you to try your hands on this. Welcome back. Let's look at it together. So now we're told that x is at 30 degrees north. So these are north, these are south, these are west, these are east, and these also are equator, which is like 0 degree, right? So 30 degrees north will be somewhere, let's say somewhere here. So this is 30 degrees north. And 10 degrees east, this 0 to 180, so 10 degrees will be very small, but I'll just make it wide just for record purposes. So these are points x, and now point y is 30 degrees north, same line of latitude, and then 40 degrees west, so it's going to just be outside. So I should have labeled this to say this is 10 degrees west, right? So 40 degrees west will still be the same place but just wider. So these are points y, and this is 40 degrees west. So if I draw my line from the origin of this point, if I connect these 2 points, that will be something like this. And if I connect to that point, it will be something like this. Right. Let me tell you one thing that we did that we did not really stress. Before we continue, if you notice, the angle here was with reference to the y-axis, right? This was our origin. I said 20 degrees, then 60 degrees, 60 degrees. You can see we took the reference from the y-axis. Same thing so we're going to do in this example. So by the time I draw this, you see what I'm talking about now. And these are points y, these are points x. Our origin will also be the y-axis. So in the y-axis, this place here is 10 degrees west. Remember, all these things, so it just depends on if the constant is the line of longitude, line of latitude. Line of longitude, this is what I hope we actually have another question that has to do with the constant line of latitude, right? So, but for this, our 10 degrees west was taken from the y-axis. So this place here is 10 degrees, and then the other side is 40 degrees. So this side here is 40 degrees, right? So the angular distance between x and y, if yet here is 40 and yet here is 10, and this is what we're looking for, so what will our angular distance be? Great, it will be 40 degrees minus 10 degrees, and that will give me 30 degrees. So you must actually know what you're doing, right? Where is it reading from? Is it reading from the y-axis? Is it from the x-axis? If it's a constant line of longitude, if it was this line and we had 2 points of latitude, the point of reference would be the x-axis, right? But if it is a constant line of latitude and different longitudes, the reference point would be the y-axis. Remember, longitude has to do with the y-axis, and then the latitude has to do with the x-axis. Right, so you can go back and cross-reference all these things to make more sense to you. Let's see if our answer is correct. Great, so 30 degrees. Now we're moving to a different concept called great and small circles. If you draw circles on the surface of a sphere, so if you take up a tennis ball, if you play tennis, that green ball, and you look at the lines around it, or you draw lines around it, you notice that the circles come in various sizes, right? The largest circle, if you see, it will divide that into 2 equal halves. That large circle is what you call the great circle. So look at this. If this was a tennis ball, you see that there will be one here, and then there will be a line that goes here and comes at the other side. These 2 lines, 1, 2, they divide that tennis ball into 2 equal halves, and that is an example of a great circle. Any other circles that are smaller than this are called small circles. So we assume that you've drawn circles, so all these other ones here, they're small circles, and the one in the middle, which is not shown here, is the great circle. So how do we now find distances along great circles? So sometimes we want to find, oh, you know, the world is spherical, so every time that somebody moves, they're moving around in circles or something about that. So you want to find how far has this plane gone, how far has this ship gone while cruising around the world or by flying around the world. It depends on if it's flying around the great circle or if it's flying around the small circle. So the great circle is basically saying the equator. If it's flying around the equator, or it's flying around the lines of longitude, or it's flying around the Greenwich Meridian line, you're going to have great circles. So the distance L along any longitude. So if we are along the same line of longitude, right, and we are told to find the distance, remember we have a line of longitude, something like this, and we're told to find distance between points A and points B. So if we have distance along any longitude at all, and distance along the equator, so we're told that, oh, something's along the equator, right? This, let's say this is the equator, or we're told to find 2 points along that equator, the equator alone, not any other line of latitude. You see, and distance along the equator among the latitudes. So it's only the equator that comes out among the latitudes. Those distances are referred to as distances along the what? Great circles. This cannot be stressed. So you can see this is the equator. So the distance between A and B is a distance along a great circle. So in this case, the L is going to be theta over 360 times 2 pi r, which is a normal circumference of a circle, where r here is the radius of the earth. You agree with me that at this point here, the radius is fully the radius of the earth along the circle. The reason why the other lines of latitude are not going to, because by the time you come here and you draw a circle here, so if I draw a circle at this point here, you see that the radius from here to that point is not going to be the same as the radius of the earth, because it's shrinking in width as we go up or as we go down. Let's say an example. It says the positions of two towns A and B are given as follows. Town A is 0 degrees north, 45 degrees west, and town B 0 degrees north, 75 degrees west. And both lie on the equator. Given that the radius of the earth is 6,400, represent this information in a diagram and then calculate the great circle distance between the two towns along the equator. Take pi to be 22 over 7. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So this is north, this is south, this is west, and this is the east, and this is 0 degree. So let's see the circle around the equator. So just draw one small circle to show that it's a circle around the equator. Great. So let me also draw it here too. It now says that this is 45 degrees east. So here I'll draw a line. So this point, because it's due north, really it's just at the equator, right? So this point here is point A, and now says 75 degrees west. So from this point here, I'll draw a line. So these are points B. So in this case here, this is the distance along the great circle, right? It's the distance along the equator. Right, so I could just say from this point here, I'll draw here. From this point here, I'll draw here. I can find the theta from there. Remember, this line here is 45 degrees east. This line here is what? 75 degrees west. I forgot to label. You must not forget though. So the angular distance theta will just be what? 75 plus 45. If you got that, clap for yourself. So that's 120 degrees. Then the distance D is going to be theta over 360 times 2 pi r, because the distance along a great circle. So this would be 120 over 360 times 2 times 22 over 7 times 6,400. So this will cancel this. This will be 3, right? So this is how far you can go. So let's now simplify this. So let's plot this. This will be 2 times 22 times 6,400 divided by 3 divided by 7. So this gives me 13,409.5, so which is basically approximately, this is also in kilometers, because the radius of the earth is in kilometer. So these are approximately 13,410 kilometers. So let's see if our answer is correct. Great. So you can see the representation, how this guy is a bit here and this guy is a bit here. I hope in the theory exams your diagram will be finer than mine. So distances between 2 points with the same longitude. We already discussed that this is also a distance along the great circle. Here we said the meridian, the longitudinal line, is always a great circle because it passes through the Earth's poles and divides the Earth into 2 equal halves. So you might not be able to picture this right, because you're looking at it in that way, but if you do the 3D view of the Earth with the lines, you see that every point on the longitudinal line divides that circle into 2 equal halves. So 2 points on the same longitude lie on the same meridian, so the formula for great circle distance applies, and we know this. So let's see a further example of this. Example 6 is that consider the 2 points coordinates of 33 degrees south, 33 degrees west, and 40 degrees north, 33 degrees west. Find the angular distance between them, and using the approximation that the radius of the Earth is 6,371 kilometers, find the distance between them to the nearest kilometer. I want you to pause the video and try this out yourself. Welcome back. Let's look at it together. So this is the north, this is the south, this is the west, this is the east, and this is also the equator. Great. So we're told that this guy lies on 33 degrees south, so I'll come to the south. Remember this 0 to 90, so 33 degrees should be somewhere, maybe somewhere here. So this is 33 degrees south, and this is 33 degrees west, so this is 0 to 180, so this place will be somewhere like this. So this point here is my point, let's just say point A, and this guy here is 33 degrees west. This other guy here is 33 degrees west, so it is still the same line of longitude, and 40 degrees north, so this will be somewhere like this. So this guy here is 40 degrees north. So from this point here, if I draw a line like this to touch this guy, and I draw a line like this, this is my point B. So if I just break this up, remember this is the same line of longitude. Right, so the reference is going to be from this point here. Remember what I said that time. So our reference is going to be the x-axis. So these are point A, these are point B. From here to here is this 40 degrees. From here to here is what? 33 degrees, because 33 degrees south, so this is 33 degrees. So our theta here is 40 plus 33, which is 73 degrees. And then our D is what? Theta over 360 times 2 pi r. Remember, in this question we told r to be 6,371. You have to be very, very careful. Sometimes, most times they will give you 6,400, but you cannot assume that it's going to be 6,400. So this is equal to 73 over 360 times 2 times 22 over 7 times 6371. So let's punch all of that into our calculator and see what we're going to get. That is 73 times 2 times 22 times 6371 divided by 360 divided by 7. And that gave me 8,120.49 something. Let me just say 0.49. Let me just approximately 8,120 kilometers. So let's see if our answer, okay, it says using the approximation, blah, 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 find distance between them to the nearest kilometer. So just like the question now said that to the nearest kilometer, so we're actually good. So instead of saying points for something, we are good here. So the angular distance said it was 73 degrees, and then the distance is 8,120 kilometers. Let's see if our answer is correct. Great. So 73 degrees and 8,120 kilometers. So now we're looking at distance between 2 points on the same latitude. Remember, this does not apply except if the latitude is the equator. But this time we're looking at every other latitude except the equator. So the distance traveled along a parallel between 2 points with the same latitude can be determined if the radius of the small circle corresponding to that latitude is known. You know, we said as it goes, right, the radius will become smaller because the radius of this big circle to the Earth's surface would be larger than the one of this small circle, center of this small circle to the Earth's surface, because it's growing smaller, unlike the longitudinal line, which is going from up to down, and is basically divided into 2 equal halves. Right? But for lines of latitude, as they go away from the equator, they become smaller. So the radius there becomes smaller. So if you look at this description, let me blow it out for you. So we have this. Let's see, we have this point. These are normal radius. These also are normal radius to that particular point B, right? So these are normal radius. But this is the small circle here. This is small circle here, and this is the radius corresponding to that small circle. Right? It might look as if it's the same. So let me just move this one longer so it doesn't look as if it's the same. Right? It might look as if, of course, it looks as if this one is smaller. So let's say these are small radius r. Right, I remember this is the angle that this one subtends. Remember when we're doing some degrees north and south, we always take it from this guy. So just see these are theta. Right, these are forming a small triangle. So if we block this place here, correct. We know this r. We want to find this r, and this is something that we've not touched yet. It's something we've not touched yet. When you have this, when we reach that place, we're going to see it, but in a Z form, where there is this place here, is this line here. You're agreeing that this line here is parallel to this line, right? This line here is parallel to this line. You agree with me? When you have two parallel lines, the angle here is also equal to the angle here. This is something that I still go to treat further. I'm just showing you the proof or the application. The angle here is the same thing as the angle here. So we know this angle, we know this r. We're trying to find this r. Remember, this is the opposite, this is the adjacent, and this is the hypotenuse. So we have the adjacent and we have the hypotenuse, right? So from SOHCAHTOA, what would that give us? Ka, right? So if you see, this is our triangle here. Then we said using trigonometry, we can use the formula for cos, which is adjacent over hypotenuse. Adjacent is r over hypotenuse. So that we know that the radius of the small circle is going to be r cos theta, and that's all we need to know when we're dealing with distances between 2 points with the same latitude, except what? Except the equator. So even if it was the equator self, you're arguing that the theta would be 0, right? So if it was the equator, theta would be 0. Cos 0 is what? Cos 0 will give you 1, so your r will just be capital letter R. That's why we don't always use r cos theta, because in that case, so it really applies to everything, right? But in that case, the cos theta is 1. Make sense? Great, let's continue. So let's look at an example of a small distance between 2 points with the same latitude. So a point X is on the latitude 28 degrees north and longitude 105 degrees west. Y is another point on the same latitude as X, but on longitude 35 degrees east. Calculate, correct to 3 significant figures, the distance between X and Y along latitude 20 degrees north, and then now find X from the equator. Take pi to 22/7 and radius of the Earth to be 6,400 kilometers. Take from Y to 2001. I want us to solve this together. So if we label it, this is the north, this is the south, this is the west, and this is the east, which is also the equator, so I could say 0 degree here. So point X is 28 degrees north, so this is 0 to 90, so 28 degrees north will be somewhere, let's say somewhere here. So this 28 degrees north, and the longitude is 105 degrees west, so this is from 0 to 180, and this is west, so 105 degrees will be somewhere like this. Great. So the point where the two meet is the point X. So I also label this to say this is my 105 degrees west. Y is another point on the same latitude as X, so this same place, but on longitude 35 degrees east, so 35 degrees will be somewhere like this. Great. So I'll just label this and say this is 35 degrees east. So these are points Y. So these 2 points are on the same longitude. So if you look at it, there's also a smaller circle, one of all those small circles that we talked about, since the 2 points are not on the equator or on the longitude. So it's going to be an example of a small circle like we discussed. So for this small circle too, you see that there is also, let me say this like the center. I know that this is not really centering, but this is like the center. Just assume that this is the center. So from this point here, it will point to this place. From this point here, it will point to this place, right? So on the y-axis, I can just blow this up and say this is what we have. So these are points X, these are points Y, these are y-axis. Right? So now we said when they share the same latitude, is always the y-axis as reference. So from here to here is 105 degrees. So of course it doesn't. This is not representing it at all, because this place is meant to be very large. But just take it like that. So this is 105 degrees, and this place here is 35 degrees. So our angular distance would be 105 plus 35. Please, whenever you are doing this, if it's a theory question, please make sure that this one is very big and this one is small, right? So this will be 140 degrees. So our theta is 140 degrees. Also remember too, from this place to this place here is our radius r, right? And for this small circle, you know, we said that there will also be a small radius r, right? Where we will now say this r is r cos theta. Remember that. Great. So we know that our formula is for distance would be theta over 360 times 2 pi r, where r is r cos theta, right? Which is the small r, this small r. We've done this before. So our theta is 140 all over 360 times 2 times, what did they say we take our pi to be? 22 over 7. What did they say we take our r to be? 6,400 times cos our theta is what? Okay, so let me not use theta and theta, let me say alpha here. So this will be cos alpha. Our alpha is the latitude, which is 28 degrees. So let's plot this and see what to give us. So that will be 140 divided by 360 times 2 times 22 over 7 times 6,400 times cos 28 degrees, and that gave me 13,813.225 kilometer. But they said we should correct it to 3 sigma figures, so that will be sigma figure 1, sigma figure 2, sigma figure 3. This is 1, so it cannot transfer anything. So this will be approximately 13,800 kilometer. Great. So the next question now says that how far is x from the equator? So this is x. Let's assume that this is the equator line, right? This line is, of course, you know, some people draw it like a circle like this to show the equator, but let's just keep it simple and make it a line. So from this place here to this place here, is what they're asking us. So let me just draw this guy here. So this place here to this place, what they're asking us. So this will be our theta, right? So if I blow that up, we'll have something like this. Let me just do it here. These are equator, which is our 0 degree, and these are points x. So between here and here, this guy rose up to 28 degrees, right? Because that is the angle of the latitude. So this theta here will be 28 degrees. And here we are looking at the x-axis as our base, right? So this guy rose up from the x-axis because it's also a line along the longitude. This from this point to this point. This is the line along the longitude. So we already have all that we need. So our distance d would just be theta over 360 times 2 pi capital letter r. Our theta here is 28 degrees, so that will be 28 over 360 times 2 times 22 over 7 times 6,400. So you can plug that into the calculator. This will be 28 over 360 times 2 times 22 over 7 times 6,400. That gave me 3,128.89 kilometer. So if I also doing it to 3 significant figures, what we thought to, okay, let's just put to 3 significant figures. So I should have even said this here. So 3SF, right? So if I approximate this will be significant figure 1, significant figure 2, significant figure 3. But the next guy is 8, so it's going to carry over 1. So that will be 3,130 kilometer to 3SF. Let's see if our answer is correct. So these are diagram. Great. So you can see the representation of this guy and this guy. You can see the angle, which is like the alpha. Then you can see this place there, which is like the small letter r. From here to here, small letter r, which is gotten by capital letter r cos theta. And you can see 13,800 kilometer and 3,130 kilometer approximately. Both of them are to 3 significant figures. Great. Example 8 now says that an aeroplane flies from town A 20 degrees north 60 degrees east to town B 20 degrees north 20 degrees east. If the journey takes 6 hours, calculate correct to 3 significant figures the average speed of the aeroplane, and then if it then flies due north from town B to town C 420 kilometers away, calculate correct to the nearest degree the latitude of town C. So we take the radius of the earth to be 6,400 kilometers and pi to be 3.142. This take from WAEC 2011. I want you to pause the video and just try something. Welcome back. I assume that you've done that. So let's do it together. So these are circle, or these are earth. This is the north, this is the south, this is the west, this is the east. Both west and east are on the 0 degree latitude, which is our equator. So it says that it flies from town A 20 degrees north. This is 0 to 90, so 20 degrees should be somewhere here approximately. So this 20 degrees north and 60 degrees east. So 0 to 90, 0 to 180, so 60 degrees should be, I'll just make it large. Great. So these are points A. So these 60 degrees east. Town B 20 degrees north and 20 degrees east. So if both of them are east, let me make this one to be the 20 degree zone. So let me just remove this label and call it 20 degrees. Let me remove this A. Let me make this guy B 20 degrees, and I'll draw on that one outward, although this now is meant to actually be, but just take it like that. So let's assume that these are A, these are B, just to make it more representative. So this is 20 degrees east and this is 60 degrees east. So here this is along a line of latitude that is not the equator, so there's a small circle that is forming. So I'll just draw the small circle here, and then this will be like the line from the middle of the circle to the end. So these are small r. Great. So from this point here, I'll draw a line here to point B, and from here I'll draw a line here to point A. Great. So we can blow this up and say these are y-axis, This is the first line, this is the second line, great, and this is the curve or the arc. So these are points B, these are points A. Point B is 20 degrees east. So if I start from here, of course, if I say here and I put here 20 degrees and I say here 60 degrees, that does not make sense. So I'll start from here. So from here to here would be 20 degrees, and this point B is at 60 degrees east. So I'll just come here. So this is 60 degrees, right? So you agree with me that the angular distance would just be, because if here to here is 60 and here to here is 20, that would be 60 minus 20, and that gives us 40 degrees, right? Great. So we have our theta. Our alpha from here to this point here is 20 degrees, right? So now the way to do it now, whatever angle we have here will be the same angle we would have here, right? So if this is 20 degrees, then that means the angle here too is 20 degrees. Now I will do it in that calculator. So our alpha here is 20 degrees. Great. So we can find the distance. So the D will just be theta over 360 times 2 pi capital theta r cos alpha. Our theta here is 40. So 40 over 360 times 2 times what they say we should take our pi to be. Always look at what they say you should take your pi to be. Don't go and do 20 over 7. They say 3.142. So 3.142 is the same thing, but the teacher wants to be sure that, or the examiner wants to be sure that you are following instruction. So cos 20 degrees. So I'll just plug all of that in. I'm not cancelling anything. So that is 40 over 360 times 2 times 22 over 7 times 6,400 times cos 20 degrees. So that will be 42002.77 kilometer. Did they say we should do it to 3 sigma figures? Yes. So this sigma figure 1 sigma figure 2 sigma figure 3 is 0. So that would be approximately 42,000 kilometer to 3SF. Great. Now it says that the journey takes 6 hours. So we know the D. So this we are seeing the IO. We know the D to be 42,000 kilometers, and we know the T to be 6 hours. Can we find the speed? Yes. So speed is distance over time, which is 42,000 all over 6. So 42,000 divided by 6, that will give you 7,000. So the speed is 7,000. But what is the unit? This is in kilometer, so kilometer per, and this is in hour. So our speed is 700 kilometers per hour. Great. It now says that it then flies due north from town B to town C. So this is town B to a town C somewhere 420 kilometers away. Calculate correct to the nearest degree the latitude of town C. So let's assume that this is town C. Let's assume that this is town C. But that town C is also on the same longitude, right? Because it's from B and it moves northwards, is on the same longitude. Because look at what this is, we just calculate the latitude, so you know that it's on the same longitude. So this is our point C. Point B is here. Point C is here. They're on the same line of longitude. So I can start from this middle and draw. So from here to here and here to here is C. So let me draw it out. And this is our B. Both of them are on the same line of longitude, so the reference point will be our x-axis. So this for the B part. From here to the B, see the B has a line of latitude 20 degrees. So here to here is 20 degrees. While the C, we don't know the line of latitude of the C, but from here to here is x. We know that is bigger one. So the smaller one here, if this is x and this is 20, so that means this place there is x minus 20 degrees, right? That is our theta. So theta over 360 times 2 pi r will give us the distance. And we're told that distance is what? 420 kilometers. So let's now do it. So that will be x minus 20 over 360 times 2 times 20, or 3.142 times 6,400 is equal to 420. So let me resolve this side. So that will be 2 times 3.142 times 6,400 divided by 360. So that gave me 111.72 multiplying x minus 20 is equal to 420. So if I divide both sides by 111.72, so our x minus 20 will be, so 420 divided by answer, that will be 3.76 if I was approximating. So to make the x standard, now x will now be equal to 3.76 plus 20, so that will be 23.76, right? And that will be in degree. But now we need to know, is it 23.76 degrees north or south or west or east? If we're going back to the question, we're trying to look for the latitude, right? And latitude is always north or south. So these are point C. Our point C is in the northern hemisphere. So of course, you can see it here. This is our point C and it's in the north. So of course, our answer will be 23.76 north. Right, but then the question also is that we should also correct to the nearest degree the latitude of C. So to the nearest degree, that will be approximately 24 degrees north. So we could say to the nearest degree. It's very important that you put the north, south, west, and east on those questions, because you will get the answers for all the steps, but you're not get for the answer if you miss out on all the symbols. So to the nearest degree. Let's see if our answer is correct. 700 km per hour and 24 degrees north. Great. Example 9 now states that a plane flies due east from A, which has latitude of 50 degrees north and longitude of 25 degrees east, to a point B that is latitude 50 degrees north and longitude 85 degrees east at an average speed of 400 km per hour. The plane then flies south from B to a point C 2,000 kilometers away. Calculate, correct to the nearest whole number, the distance between A and B, the time the plane takes to reach point B, latitude of C. Take radius of the Earth to be 6,400 km and pi to be 22/7. I believe this is something you should be able to solve, so I want you to pause the video and try this out. This is taken from 2005, by the way. Welcome back. Let's solve it together. So these are north, these are south, these are west, these are east. So a plane flies from A is 53 degrees north, so this 0 to 90, so 53 degrees should be somewhere here. So 53 degrees north, and the longitude is 25 degrees east, so 0 to 180, this should be somewhere here. Great. So this is 25 degrees east to a point B, 53 degrees north, still the same line of latitude, but 85 degrees east, so this should be bigger. Great. So this 85 degrees east, but they have the same. So wait, let me just put this place. This point A, this point B. So but they are the line of latitude, they have the same latitude, so I'll draw a small circle. So from here to here, this is my small letter R. Correct. So the points will be from here to here and then from here to here. So it says find the distance between A and B. So let me just blow this out. So we have this, we have this. I'll draw this. So from my y-axis, which will be my line of reference, this guy here, A is at 25 degrees east, this guy is at 85 degrees east. So from here to here will be 25 degrees, and then from here to here is 85 degrees. So these are point A, these are point B. So what will be our angular distance? Great. That will be 85 minus 25, and I'll give you 60 degrees. So what is our distance? Our distance is just theta over 360 times 2 pi r cos alpha. What is our alpha? Our alpha is the latitude, really. So if I do year to year, right, it's the same angle here, same angle here, which is 53 degrees. So our alpha is 53 degrees. So our d will just be 60 over 360 times 2 times what is, we should take our pi to be 22 over 7. Great. So times 22 over 7 times 6,400. I assume that is what they said we should be, but let me just check. Great. So times cos 53 degrees. So this can go here 6, 2 here 1, 2 here 3. So let's solve. So that will be 1 over 3 times 22 over 7 times 6,400 times cos 53, and that gave me 4,035. So it says we should do it to the whole number, to the nearest whole numbers. That is approximately 4,035 kilometers. So to, let me just roll this up down to the nearest whole number. Great. So we have found the distance. For the B, it answers that we should find the time, but we're told that it had a speed of 400 km per hour. So we know that speed is equal to distance over time, right? And we're given the speed to be 400, and we know that the distance is 4,035. So all over the time, if I cross multiply, so that will be 400 times t is equal to 4,035. But the Bible says by 400, my t would just be, let me do that, 10, approximately 10 hours. So approximately 10 hours. Great. Now say that we should find the latitude of C. But what they say about C? They say the plane then flies south from B to a point C, 2,000 kilometers. Wow. So if it flies south, it could be here or it could be inside here, right? It could be inside here or it could be inside here. Those are the two possibilities. So when you have two possibilities, I wish I to err on the side of caution. It could be here, it could be here. So let's take it inside there and see. So let's say it could be here, right? From B, where's B to C? So this would be this point here. So if I join this place here, this would be my point. Let me just see, right? So it would be something like this. But if it's somewhere here, right, let's say this is the point C, it would be something like this. So either my diagram is like this or my diagram is like this. Is one of these two, but one of them will go at the end of the day. So let's see. So the latitude of C, so let me just draw the two cases. So it could be something like this, and this is the x-axis, right? So we're year to year. Yeah. So this place is at latitude what? 53 degrees north. So year to year will be 53 degrees, and here is x. So our angular distance would be, our theta here would be 53 minus x, right? So this is one possibility. These are B, these are C. Or the second possibility is this guy here. It could be like this, or it could be like this, where these are B and these are, sorry, where this is our C and these are B. So what will have here will be one big theta, where year to year is 53 degrees, and year to year is x degrees, right? So it could be one of these two, where the theta here in this case will be 53 plus x. So let's see. Remember, it's a line along the same longitude, so we are fine. The distance is 2,000 kilometers. So let's plot. So let me use this first one. So our d here will be theta over 360 times 2 pi r. I think they said the d is 2,000 kilometers, just to be sure. 2,000. Great. So that will be 2,000 is equal to 53 minus x all over 360 times 2. The pi is 22 over 7, and then the r is 6,400. So let me just resolve. So that would be 2 times 22 times 6,400 divided by 7 divided by 360. So that would be 2,000 is equal to 53 minus x multiplying 111.75. So if I divide both sides by 111.75, 2,000 divided by 111.75, so that would be 53 minus x is equal to 17.897. So yeah, minus x will now be equal to 17.897 minus 53. So if I minus 53 from this, and I divide my, let me just come over here, I'll just say my minus x is minus 35.1 degrees, right? And if I divide both sides by minus, my x is 35.1 degrees. But now this 35.1 degrees, we need to know, is it north or south or what? So we're looking for the latitude, right, of this C. If it was this guy here, you agree with me that it's still in the northern sphere. So this one will be north, 35.1 degrees north. Look at the C. You see that it's still within the north. So this will have been 35.1 degree north. If it was also that guy, what will have happened? That all of this will still be the same, right? All of this minus, this place will just be plus, this will be plus. So all this up to this point it will still be the same, and that will be 53 plus x is equal to 17.897, and the x would be 17.897 minus 53, and then that will be equal to minus 35.1 degrees. So if you look at that place, in this case here, it would be in the south, right? Because you can see this way it is in the south. So degrees south. But this cannot be correct because the x is a negative value. You choose the one that gives you an x of a positive value. That means that our answer is actually 35.1 degrees north. But the question also says that we should correct the nearest whole number. So that would be, if I come down here, I could just say x is approximately, that would be 35 degrees north. So that's how we solve questions like this. Let's see if our answer is correct. Great, to see our diagram, and then you see 4,035 kilometers, 10 hours, and 35 degrees north. Great. Example 10 now says that K, with a latitude of 60 degrees north and longitude of 50 degrees west, is a point on the Earth's surface. L is another point due east of K, and the third point N is due north of K. The distance KL is 3,520 kilometers, and KN is 10,951 kilometers. Calculate the longitude of L, the latitude of N, and take pi to 22 over 7 and read over there to be 6,400. Let's take from 2004. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So this is the north, this is the south, this is the west, and this is the east. So for point K is at latitude 60 degree north, so this is 60 degree north, and 50 degrees west. So this 0 to 180, so 50 degrees west will be somewhere here. So these are points K. L is another point due east of K, so that means it's on the same latitude, right? Do we know the distance? So we don't know. I'll just draw. So these points L, right? So there's a small circle here because on the same latitude. There's a line here. So these points here and these points here. Great. So let's take the point of K and L first, so that will not complicate things. So if I blow this up, this is K, this is L, so this is the reference line. We're told that the longitude of this is 50 degrees, so from here to here which touches this line here is, remember, they share the same line of latitude, so this 50 degrees. But from here to here, we don't know the longitude of this, so this will be x. So what will our angular distance be? Great, so that will be 50 plus x degrees. Another distance, KL, the d is 3,520 kilometers. And then because it's a distance along the small circle, we will need our alpha. Our alpha is just the angle of the latitude, which is 60 degrees. So we can plot and say d is equal to theta over 360 times 2 pi r cos theta. So that will be 3,520 is equal to 50 plus x all over 360 times 2 times 22 over 7. I assume that would the take our pi to be, yes, so 22 over 7 times the let's take our r to be 6,400 times cos alpha. So this should be alpha, which is 60 degrees. So let's solve. So that will be 3,520 is equal to 50 plus x, 2 times 22 times 6,400 times cos 60 degrees, then divided by 360 divided by 7. So that is 55.873. So if I divide both sides by 55.873, that will be 3,520 divided by answer, and that gave me 63. So 63 is equal to 50 plus x, right? Because this will cancel this, so our x will just be 63 minus 50, which is equal to 13 degrees. So our longitude is 13 degrees, but is it west or east? So you can see this is the west, this is the east, but these are L, right? And it's in the eastern direction, so that's 13 degrees east. So it now says that we should find the latitude of n. So let's continue our question. Our question now says that and the third point, n is south of k. So this k, south of k. So it could be here, it could be here. I'll just take one point really. So this point here is the n. So we have the k, we have the l, we have the n. If I wanted to draw the line, that would be something like this to k and this to n. So let's blow it out. We have this, we have this, and we have this. So these are k, these are n, right? And these are x-axis, because they are both points on the same longitude. So what are we told? We're told that distance is 3,520. We've done that for this, but the distance in kn is 10,000. So just say kn is 10,951 kilometers. So we're told to find the latitude of n. From year to year, this guy here is 60 degrees north, right? Because now they have the same line of longitude, so it's a line of latitudes that are different. So from year to year is 60 degrees, so year to year is 60 degrees. But year to year is unknown, so we'll just put as x. So our theta is 60 plus x degrees, right? So we know our distance d is theta over 360 times 2 pi r. Our d is 10,951. Our theta is 60 plus x all over 360 is multiplying 2. It's multiplying 22 over 7 times the r, which is 6,400. Great. So let's simplify. 2 times 22 times 6,400 divided by 360 divided by 7. So this 10,951 is equal to 60 plus x multiplying 111.746. So if I divide both sides by 111.746, what am I going to get? This will cancel this. So 10,951 divided by answer, that gave me 97.9 9999999. So this is equal to 60 plus x. So if I collect like terms, that would be x would be equal to, I can just say this 98. So 98 minus 60. So x would be approximately 38 degrees. But is it to the north, to the south, to the east, to the west? We don't know yet. But what we know is that we're looking for the latitude, right? And latitude is how much to the north or to the south. And this guy, we're told that this guy is to the south of k. So we can assume that our value will be 38 degrees south from our diagram. So 38 degrees south. So based off of our representation in the diagram, we are saying our x is 38 degrees south, approximately. That's the whole number. Let's see if our answer is correct. Great. So example 11 is something you're going to do by yourself. I want you to pause the video, try it out yourself, knock yourself out, do it step by step as we have been doing it. If you have any question, any correction, anything that you need me to help you with, drop in the comment section. I will help you, but I want you to do this by yourself. So pause the video now and try it by yourself. Welcome back. So if you did it correctly, your answer should be looking like this. This is a rough representation. Probably your equator line is just straight line and beautiful. There is no, you just know what you are doing, right? And then your answer should be 34 degrees north and 4,632 kilometers. And with this, we've come to the end of longitude and latitude, and in general lines and perimeters. I want you to take time to go through everything again, solve as many questions as you can, knock yourself out, and ensure that you know everything about this particular concepts and the topics I've treated so far under this. I'll see you in the next video, and happy new year to you. Bye for now.